Okay, we're going to start chapter 8 today, and we just finished up chapter 7, which was all about polynomials, and one of the things that you had to consider about the polynomial is what degree it was, whether it was a linear, degree 1, a quadratic, degree 2, cubic, degree 3, and so forth. We're going to start looking at quadratic functions. Okay, a quadratic function is when the degree of the polynomial was degree 2. So this is y equals x squared. So since we have a squared term, that's our highest exponent, then it's degree 2, which makes it a quadratic function. So what does a quadratic function look like? Well, if I want to graph a quadratic, I do the same thing that I did in the first semester when we were graphing linear equations. We're going to make a table of values, and we're going to put values in. Now we wanted to put negative values in and we wanted to put positive values in. So I may put in a negative 2, may put in a negative 1, 0, 1, and 2. Now I'm going to put 5 values in. We don't always need 5 values, but in this case I'm just going to go with 5. And we're going to plug them into the equation. So when I put negative 2 in, it says y equals, it would be negative 2 squared. What do I get when I square negative 2? Well, I get a positive 4. When I put in a negative 1 and I square it, I get a positive 1. When I put a 0 in and square it, I get 0. When I put in a positive 1 and I square it, I get 1. And when I put a positive 2 in and square it, I get 4. And what you're going to notice with quadratics is you're going to see values in your y column that are going to repeat. Like you see 4 in there, and you see 1 in there as well. You're going to see repeating values, and that's what we expect out of a quadratic. Okay, when I go to graph these, negative 2, positive 4, it's right here on the graph. Negative 1 and positive 1 is here. 0, 0, 1, 1, and 2, 4. Okay, and what I get is a U-shaped graph. Now don't use straight lines and make it a V, but we want to use curves. So we curve down and we curve back up. And it's a U-shaped graph, not a V-shaped graph, but it's a U, and we call that a parabola. A parabola is another name for a quadratic equation. So in semester 1, when we graphed linear equations, we got straight lines. When we graph quadratic equations, we get what's called a parabola or a U-shaped. Okay, we call this the parent function. This equation right here, y equals ax squared. A is a constant, so a can be 1. In this case, a is 1. But we can have other constant terms there. For example, with this, we have y equals 2x squared. In that case, your value for a is a 2. That can change. But we call this the parent function. It's the very basic function. No, nothing added to it, nothing subtracted from it. It's just y equals x squared. And you can see that the vertex, or the lowest point in the graph, is at 0, 0. Okay, and it goes up from there. How does it affect the graph when we change the a value? So in this case, we're going to increase it from a 1 in the parent function here to a 2. Let's see what happens. I'm going to do the same thing. I'm going to put in x values, and I'll use the same. I'll just do negative 1, 0, 1 this time. We could put in negative 2, and we could put in positive 2 as well. We'll see what happens with these three. So if I put in a negative 1, I would have y equals 2 times negative 1 squared. Now when you evaluate that, do you multiply the 2 times the 1 first, or do you square the negative 1? Think of PEMDAS. Okay, PEMDAS says we do exponents first. So I'm going to square the negative 1, that makes a positive 1, and then take it times 2. When I put a 0 in here, 0 squared is 0, times 2 is still 0. When I put a positive 1 in there, I square the 1 first, then I take it times 2. And again, you see those repeating y values. Okay, so I'm going to go ahead and I'm going to plot that. Negative 1 is up to 2. 0, 0. And 1 is at 2. Now, what happened to my U-shape? It's still a U-shaped graph, but it got thinner, it got more narrow, it's skinnier. Okay, it's going to go up more quickly. So as that value, that a value increases, gets greater than 1, you're going to see that parabola become thinner, and it's going to go up more quickly. Okay, when that value is less than 1, okay, so up here that a value is 1. When it becomes less than 1, when I make my table of values, and I'll use the same values again, -1, 0, 1. When I put the -1 in there and I square it, I get a +1 times a half. Put 0 in there and I square it, 0 times a half. When I put a 1 in there, I get a +1/2. So when I plot those, get -1 is at a half, 0, 0, +1 is at a half. Now maybe that's not enough to show the true shape of the graph, so that's where we may want to plug in another number. Let's put a 2 in there. 2 squared is 4. 4 times a half would be 2. Okay, so if I go 2, 2, I kind of get an idea. If I put in a -2 and square it, that's +4. Okay, so you're going to see the same y value. So you always have points that mirror each other. So what happened to that U shape? Well, this time, when it becomes less than 1 or is a fraction, you see that U kind of opening up and flattening out. It gets more shallow or spread out. Okay, so that's how that a value is going to affect. If it gets bigger in number, you're going to see the U get more narrow, and if it gets smaller, you're going to see the U flatten out a little bit and become more shallow, wider. What do you think is going to happen if the a value becomes negative? Okay, well, to find out, put some values in. Make a table of values, put in your -1, your 0, and your +1. See what happens and see if that's what you predicted. Okay, so if I go -1, if I fill out my table, get -1, I'm going to get a -3, 0, 0. Okay, so now what's happening to my parabola? Well, it turned and it went down. When that value is negative, your parabola is going to go from going up to going down, and it also is much thinner because that's a 3 instead of a 1. So we got two things going on. The fact that it's gone from a 1 to a 3 makes it thinner, and because it's negative, it's now going down. Okay, how does the k value affect? Well, what we call that k value is if there's anything out here adding or being subtracted, how is that going to affect our parabola? Let's do a couple of these and see what happens. If I make my table of values and I put -1, 0, 1 in here, keep in mind you have to follow PEMDAS when you plug values in. Okay, so when I put a -1 in, I square first, that's a +1, and then I have to add 2. So I get -1, 1 plus 2 would be 3. If I put a 0 in here, 0 squared is 0 plus 2 is 2. If I put a 1 in there, 1 squared is 1 plus 2 is 3. Again, I see those repeating y values, and when your y values start to repeat, you really don't need to add any more numbers in your table. You've got both sides of the parabola. So I've got -1, 3, 0, 2, oops, 0, 2, and 1, 3. Now again, you don't have a whole lot to work with, so maybe you want to put in a 2 just to see how quickly it goes up. If I put a 2 squared in, I get 4, plus 2, I get 6. 1, 2, 1, 2, 3, 4, 5. That's a little bit off the graph. We know it's going to mirror on the other side. It's going to be out here. Okay, so there's your graph. Okay, what happened to it? It's the exact same shape. Okay, this is a 1x squared, so it's the exact same opening. It's just that +2 has moved it up 2 on the graph. Okay, so what's the prediction here? If I make a table of values, that -3, what do you think that's going to do to the parabola? You're right, it's going to move it down 3. That vertex, so that low point, is going to start down here at -3, and then it's going to go up in the same manner that the parent function did, okay, because it's still a 1x squared. So you can fill out that table if you want to. Okay, and then at the end here, you've just got all kinds of things going on. You've got maybe an a value that's a fraction, so we expect that parabola to get wider or get bigger across, and then we're We're going to see that minus 2. We're going to expect the vertex to go down. Okay, we're going to locate that by putting values in. Put in a -1, put in a 0, a 1, a 2. Figure out what your y values are, and then go ahead and graph it. But those are things that we expect to see. Okay, give it a shot.